Hi there, welcome back to the channel. This is the second video in the restoration series for the Philips 461A, the 85-year-old lady. And if you're regular on my channel, you'll realize that I probably skipped a couple of video deadlines. And the reason is working on this radio was a little bit more daunting, a little bit more meticulous, a little bit more careful than I usually am. With the 50s and 60s German tube radios, it's actually something I do, well, a lot easier, almost automatic. With this one, I had to do some thinking for various reasons. One, it's an age group, it's a vintage I'm not quite accustomed to. And two, it is a Philips, and it being a Philips, there are always a few quirks. I had to do some study of the schematic. I had to make some decisions as to the wiring. I think I've made the right ones and I'm on the right track, but I'll show you that when we get in a bit closer. In the meantime, I have had to focus on one important goal, and that is everything I did here, I had to recheck to make sure that it was still receiving, because it started off receiving, and the last thing you want to do, especially when you're messing around with wiring, is to get something wrong and lose that reception, because if you lose that reception, then it's difficult to come back to it and find out what you did wrong. So far, I have been extremely lucky, but I'm running ahead of myself here a bit. Let's have a closer look and see what we're looking at. Before continuing, I just want to tell you about the sponsor of this video, PCBWay. My modest needs have been more or less limited to the simple two-layer boards at incredible prices and really quick turnaround time. But depending on what you want, you can go into the advanced PCB section, where you can get anything from rigid flex PCBs, multi-layers, up to 40-layer boards. Anything that you need, I'm sure you'll find there. They also do PCB assembly, so you can take your prototype all the way from design through to the manufacturing and assembly. Whatever you need for your prototype, you'll get with them. Links are in the description below. I actually started this off doing the usual routine, which was focus on the power supply, then go to the amplifier stage, then go to the IF and the radio sections. In other words, work backwards. However, this is where it gets a bit difficult. I couldn't really do that because of the interrelation between the wiring and the parts that I had to desolder to replace the wiring. You'll understand in a second. I did start with the power supply, remove the speaker, obviously, and I've got these two for testing. I can connect the test speaker on here, but this is the power supply on here, and the mains comes in there and it goes out to a switch. It comes along those brown wires here, which I've replaced, and I'll explain my logic for the color coding in a second. And this is a switch that switches both the live and the neutral, full isolation with the switch, and that needed some serious cleaning, but it's working. And so the mains comes in here, goes back out there, and it goes to the voltage selector at the back, which you can sort of just see over there. That allows us to switch between, I think it's 245, 220, and it goes down all the way to 110, I think. So that had some serious problems with the wiring. In fact, most of the wiring was dried up, so I had to replace that. And then after the power supply itself, it feeds three things here. It feeds this block on the right, it feeds this block on the left, and it also feeds the heater wires or the heater supply to both. And also to that tube, that's the rectifier tube, and to the dial lamp. Now, I was fortunate in one thing. These two capacitors are not original. They've been replaced. In fact, I don't really understand these date codes, but they are definitely not the originals, because I noticed the values are different on there. It says here 50 microfarads, and I believe I'll look at the schematic. But I tested these. These are very easily accessible. You can just take them off the bottom here. You see, this one is on that plate, and all it has is that wash over there, which holds it down. Same with the other one, easily accessible from the side. So you can take it out, but I did desolder everything, tested them, tested for leakage. They're actually in very, very good condition. So I decided to leave them. I could have resuffed them, and I can still do that in the future. There are very few wires connected to there, and they are easily accessible from the sides. So for now, those are fine. And also, I don't remember hearing hum when I tested the radio. So that's a good thing. So firstly, I did the replacement of components on here. There was one death cap over there. Replaced that one. The other component, there's only one other component on here other than the transformer, is a big power resistor over here. That thing there. Perfect. It's in perfect shape. No problem at all. Value is fine. Value is actually incredibly close. So that was just cleaned up and put back there. The casing of this section was cleaned up quite a bit. And also at the back here, that all got cleaned up. Those were cleaned up as well. These I actually had to remove. I removed this completely to allow me to replace these wires. The two that go to here, in other words, the mains in, this, because I removed it, I managed to solder straight onto here. The other two, in other words, the return from the switch that goes to the transformer and the voltage, the input selector, what I did was I cut the originals ones here. I soldered the remaining new wires, and then I put heat shrink on there, pushed the heat shrink all the way as close as I could to the back there. The reason is that I didn't want to dismantle this whole thing. These wires are, try it, they're crusty. I mean, I had to replace a lot of them, but some of them I just can't get to. There's a few linking from the top and to the bottom there. And I didn't want to create more problems than I had. So that was completely fixed up, and it's looking good. And I had decided that obviously this was the section that I was going to handle second. The reason I've not closed this yet is that there are still a couple of crusty wires that go to that end. Remember, this is producing B+ over here, and there is actually two high voltage sections here divided by this resistor over here. One is the pure B+, the other one has been dropped by this resistor, so I call that B2+. And this feeds various parts of the circuit. It feeds that end, and it feeds that chassis section on the right, which is the sort of radio front end and intermediate frequency as well. So these crusty wires are supplying the B+ to that side. I did not want to do them both at the same time. For obvious reasons, I've got this thing working. Let me take it one step at a time, and that's what I did. So I started replacing wires, and I thought I'd get away with replacing some wires, leaving others in, maybe just, pushing some heat shrink across some of them and keeping them. But in the end, hey, this thing was so crusty, I decided to do practically the lot. At least all the wires linking this section to there have been completely replaced. I did change something, as you can probably notice. There was no color convention on here. Everything looked yellow, if that is yellow. I mean, look at that. But it is indeed yellow. When you melt the sleeving and you get down, you can see it's yellow. So everything was yellow, and I didn't want to keep it that way. So what I did was I decided to change a couple of things. I kept most of the wires yellow with two exceptions. One was this mains in and out, okay, to the switch. And the others were the heater wires. I decided to make them white. So I'm going to keep the convention that everything that's 6.3 volts, the heater wires for the tubes on the left and the right, will be in white. So took that to that end and started working on this section. Now this gets interesting. There were quite a few of those big caps over here. 1, 2, 3, 4. Those were completely messed up. Those are those big black Phillips tar capacitors. They always are bad, so they all got replaced. Funnily enough, not one of the resistors was out of spec. Everything was in perfect spec. Well, perfect. These things are 20% resistors, but I don't think any one of them was more or less than 10%. So I left them all in because I wanted to keep some sort of, some sort of original look on here. And if I replaced all the capacitors and all the resistors, I might as well just, take this off and replace it with a little SMD module. That's going to extremes, obviously. But I started taking stuff off, and I found another thing here. There's another sort of B+ filter stage here with a 22. It had a 20 microfarad capacitor. That thing was completely open. That was replaced here with a, 22 microfarad, 450 volts. I put some of the heat shrink on because I had to extend the leads. So that is now a new capacitor. There was absolutely no filtering at this stage. It was doing nothing, that capacitor. So this should be better now. all the wiring here, as you can see, has been replaced. And the problem was I couldn't follow my normal rule of, taking it one small step at a time, because when you remove this to get that wire off, you remove all these components as well. So you might as well test them, and you've got to find out where they go in the circuit. So basically this whole section was done in one go, which left me kind of nervous because I had to remove almost everything in order to get the new wiring in. And it's worked very well. The routing of the wiring, the actual lead dress, I've kept it as close as I could to the original. In other words, the places where the wiring passes is where they were before. Oh, this was removed because I had to get to the back of this tone control. There's a capacitor coming off there and a wire coming off the other end. So that was removed, so it allowed me to clean the back a lot easier. And what else can I tell you? Well, there is one other component I decided to leave on here, and that is these guys. These are the mica caps. They look a little bit grotty, but they are measuring almost exactly what they're supposed to be. You can identify them quite easily on the schematic, and they measure perfectly. So I decided to leave them. There's 1, 2, 3 down here. So they're staying. I could replace them with micas. They're very small value. I think they're sort of, 50 picofarads, 250 picofarads, 100 picofarads. So they're quite easy to get, but I wanted to leave that in there. I can always replace them if I want to later, but I don't think I'm going to need to. And so this was the power and output section. Just to clarify, this is the output power tube. And then we've got one below, that one there, which is a detector. That's got 2 diodes and a triode. Yeah, that's a dual diode triode over there. But that receives the RF, and it detects it and converts that to audio. And it does the preamplification of that first audio section. And then, of course, it passes it on to drive the power tube. And then down below here, we've got, that's an IF amplifier down there, that one. I'm just looking at the schematic on the side here. That sits between 2 IF transformers. Now, the transformers, this is one of them here. And this is a strange one. I'll talk about that in a second. This one is between that IF transformer and the one that comes from the previous one, which is in the other block at the other end, right at the other end, right? So this signal that comes in here is actually an IF frequency that comes through here, goes to there, gets amplified, goes to that IF transformer with the detection being made at that tube over there. So there's actually quite a distance between the one IF transformer and the other one, which is a little bit, a little bit weird. There's another few things. There are another few things here that are weird, but we'll get to that in due course. So everything was replaced here, and there was one great concern that I had, and that had to do with the lead dress. You see, these wires here that go across here, let me tell you what they are. The white ones are heater wires, lots of current. These tubes draw quite a lot of current, and they are in parallel. So you add the currents of each. I think the top one by itself is about 1 amp. So there's quite a few amps going through there on those white wires. Then there is the intermediate frequency, the carrier with the modulated signal on it that comes to this IF amplifier. Then there's also supply, B+. There's the main B+ that comes to the power tube at the top. It gets broken down into a few more supply lines, and one of them actually goes back. This resistor receives one of the B+, supplies the tube. I think it supplies the grid. I'm not sure now. Yeah, I think so. And then it breaks it down, brings it down a bit with this resistor, and it sends it off again to the block on the other side, which needs that voltage. So this whole thing is really strange. It's all broken up with different sections, but the most important thing is this loom over here. Now, admittedly, they hadn't loomed it. I did. I tied these together to keep them neat, and I might have to undo them. We'll see. But this loom over here carries 6 volt AC for the heater wires, lots of current. It carries an IF signal, which is pretty low voltage, but it's at 400 and... Actually, no, this IF is about 200 and something kilohertz. I'm not sure exactly, but I'll check. So it carries that IF frequency with the audio on it, with the information on it. It also carries B+, and it flows together without really being wound. So you see it flows all the way through here. It goes there to the supply for the respective supply lines. That's B+, B1+, B2+, and the heaters. But this signal along here is actually our audio signal, or rather our IF signal, and everything is together. There's no real shielding between them. Now, the only explanation I can find is, because it does work, the only explanation I can find is that because these signals are at a fairly high level, in other words, this IF signal coming on here is not at the microvolt level, okay, where it would definitely pick up hum and noise and everything else from the other wires. It's probably on the volts level. So it's been amplified at that end by the, what is that? The mix oscillator would have amplified that signal, and it will bring it across here at a pretty high, relatively high voltage level compared to what it would be on the right-hand block. So maybe that's the reason that it doesn't really interfere. It is still, contrary to just about everything that I learned about lead dress in tube equipment, you should keep these signals separately. You should keep the heaters very tightly wound. In other words, these two wires here, the white ones, which are sort of lightly wound, because I wound them together first, and then I did these, and then I did the others. The ones that go to that side are wound together by themselves. So each one is individually, each group or pair is individually wound, and then they sort of all get stuck together. But they're not tightly wound. You know, when I build I've done a tube guitar amp, the heater wires are screwed, you know, you put it at the end of a drill and you twist them so they literally are sort of completely tightly wound, like one unit, so that the common mode noise interacts with both sides, and it sort of cancels one cancels the other out. Never mind, this is what they did. This is Philips. This is 85 years old. Who am I to tell them how to do their job? They know what they're doing, or they did know what they were doing, and the fact that it's working today, or was yesterday, we shall see, well, it really sort of tells you that perhaps they did know more than I do. And I'm sure they did know more than I do. But anyway, one final look at this. This thing is actually looking very, very good. Very good indeed. I could not be more pleased. I really am surprised that I managed to get this done. And of course, the other side got done too. The cleaning was the best that I could do. This is not cleaning too easily. This is not rust on there. But it is not surrendering to the usual products or the usual methods. I did try here with a little bit more aggressive version of the cleaning. I don't like it. I think it's it takes away from the original patina, so I decided to leave this. There's absolutely no dirt on these sections here. The output transformer, which was in really bad shape, is now looking good again. It's clean. It's looking really good. The tubes have been cleaned as much as I can. And you can see the patina on here that doesn't come off. You can see it quite clearly on that tube shield. If I tried to take that off, I'd have to sort of sand it down, you know, polish it down. And I don't want to do this to this radio. That would look a little bit weird. Same applies for this over here. This is definitely not rust. It's been thoroughly cleaned, and it just won't come out any better than that. So that's the way it's going to stay. There's one more thing I want to tell you, and that is, you see these two wires going to the right-hand side here. I had decided to do only that section first, but because these two are actually the signal coming out of that end going to there, and I could have brought it to here and, you know, cut these wires and then join them, but I decided just to do the whole job. They actually went to two fairly accessible points. One of them is here and the other one is over there. So that means that I don't have to worry about more wires coming from that end. There are still a couple or a few coming out here from the power supply to this section. But let me show you what I'm facing. This is what this looks like. This one is actually worse than the other one. This is really... Actually, you know what? I'm saying that, but when I think about it, when I looked at the other side, it looked more or less like this as well. I think it just gets easier when you start removing some really big capacitors and replacing them with the modern ones, which are a lot smaller, and space suddenly becomes available. So I guess I shouldn't be that scared of this. Yeah, I still am. Well, fortunately for this radio, I found a pretty good schematic and, in fact, the whole service manual. I've got this whole service manual here. It is in Dutch, so I can probably understand some of it, but it's pretty well documented. And as usual with Philips, they provide these drawings. These drawings are always very useful. You can actually follow the wires to their respective points. It gets a bit difficult to see them sometimes, but you can. And as you can see here, we've got the section that I worked on. This was that big capacitor there that I replaced. And there's the tube, the output tube. This is the detector and preamp. And that's the IF amplifier tube over here. We can also see the other side. And indeed, there is a power supply one as well. Over here, I think. Yes. Oh no, this is the overview. If you can make anything out of that, your eyes are better than mine. But yeah, okay. We can get some idea of what's going on. You can sort of see the numbers. Well, not really here, but these wires are numbered and you can follow the numbers all the way through from one drawing to the next. It's very, very useful. The problem with this is in the schematic. And as you can see, there are no component values. This has got the component numbers, C38, R18, etc., etc., etc. So when you look at this here, you then have to go back to this service manual, and over here, here it is, your resistors are here on the vertical, and they give it to you in ohms, okay? And your capacitors are over here, and again, as we can see, the capacitance values are all in microfarads or microfarads, which is picofarads. And these are normally values you don't see much anymore. For example, 40 picofarads, you don't get that, you get a 39. 50, you don't really get that, you get 47 or 56. But they're close enough, they're good enough. And this jumping backwards and forwards between the schematic, looking at the component number, and coming here to see what that component corresponds to, makes this a little bit more difficult. Now, what I've tried to do here, as you can see, is I've again color-coded this. The obvious ones like that there, that is obviously a changed component. I replaced that capacitor, that capacitor, that capacitor, that one there, etc., etc., etc. My usual convention, okay? And then things like the wiring, well, here, this is the other one. These resistors measured fine, so they are painted in green. They were also part of a connection that I didn't need to replace the wiring on, so they're in green. The reason for this is that usually they're just a component that's connected to a joint point over there. In fact, this is a good example. This point over here is one of those quigs or quiquettes or pigtails or whatever they're called, which many of you have informed me were original. They used them in these radios and other radios from the era. So this was not a botch or a repair. This is a quig they put on here, and you've got 3 components that are stuck in it. And then this component goes straight to the tube pin over there. That goes to another quig over here. And this resistor goes to ground, if I'm not mistaken. Yeah, which is a connection point on the chassis. So this point over here did not require any replacement wiring. The replacement wiring is marked in orange. All the orange is the replacement wiring. And it got a bit confusing because obviously this is one schematic. From this tube forwards, it's in that chassis block that I restored. And then everything to the left of that is in the chassis block on the right-hand side that I still have to do. So you can see that between this and this, there's actually that long wire. That's the wire that brings us the signal from the one side to the other, which I mentioned, which I was worried about picking up hum. Also, some of these supply lines, like, for example, from this point onwards to there, I'm trying to think of which one. Oh, here it is. From this point onwards, from this point to there, this resistor is on the block that I've restored, but that point there is on the other block. This is that one supply line that goes right across the radio. So you have to jump backwards and forwards. And again, it sort of does away with my method of trying to keep this thing orderly, you know, power supply, power amplifier, preamplifier, IF, blah, 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 blah. Okay. But the point is, it got done. And as you can tell, all I had to replace were capacitors, and not all of them, because some of these, that one there, that there, those two were those mica ones. But there are a few things that actually stuck out for me here. I looked at this IF transformer. This is that IF transformer in the block that I had to restore. And what you'll notice here, normally when you tune an IF, you adjust the actual cores inside the coils. Well, these aren't adjustable coils. These are fixed coils. And I noticed there's no adjustment possible over here. So I tried to figure out how the heck you tune this thing. And I realized what it is that these capacitors are variable. But these variable capacitors are strange because they're actually not trimmer caps. They are a wire that's wound on a little tube, almost like, yeah, very similar to a coil. And you put in more turns or less turns, depending on how much capacitance you want. So to tune these things, it's not easy. It's not precise. It's sort of take a turn off, measure it, take a turn off, measure it, put a turn back, measure it. So it's not easy to tune this particular transformer. I've noticed that the other transformers seem to have adjustments at the top. So I think in those cases, these two caps may be adjustable internally, but I'll get to that when I get to that. One other thing I noticed is that there was actually a mistake here. The way it was wired, the speaker, the output, or rather the secondary of the output transformer, had no reference to ground. Okay, this connection, this orange, was here. The connection to the loudspeaker is the wire that I've shown hanging in the breeze there. But there's a connection to ground. This dotted dashed line at the side here is chassis. And the output, the back output for the speaker is connected to chassis, but this red wire here did not exist. And I noticed that on one point at the top, there was actually a little piece of yellow that had been cut. And I realized somebody had cut this wire and not put it back to the speaker, because the speaker works perfectly well without it. This secondary is floating if it's not connected to ground, but it produces the audio on the speaker, so that wasn't really necessary. But I put that back anyway. And I think that's about it so far. All that's left for us to do is to test this thing. And to test it, I'm going to plug it into the dim bulb tester. I've got the switch over here that I've rewired. So AC comes in, it comes to the switch. I don't know what this is. This is not on the radio. Sometimes this is internal to the transformer. It's a heat trip function, so it overheats. If it overheats, it trips, but I don't see anything that can actually that could be. It could be that this is indicative of the voltage selector, but it's not drawn the way I expect it to be. But anyway, you switch it on, power comes on, and this thing powers the radio. And as we know, it works. It has worked in the past when I tested it. And as I've been doing the various bits, I would put the tubes back and try it again, just to be safe. So I'm going to show you the result, and we'll see how to go on from there. So I've got this ready. I've got the one light bulb on, only 40 watts. Everything else is off. The limit action is on. That is on there because the switch is now operational, so I don't have to worry too much about that. I've got the mini whip antenna connected to the back there. And I think we're ready. I've got a speaker connected on here. So let's go. The light bulb there went sort of bright and then down, and now it's sort of starting to go up again, which is what we expect. Everything good so far. Put the volume up. And we have it. And this thing is seeing 177 volts, drawing 120 milliamps. That's with one light bulb on. If I give it another one, the voltage goes up to 202, 150 milliamps. All good so far. You'll notice that I wound a dial string just on this front section, just to make it easier. This is our medium wave. That's our local station. So medium wave's working exactly the way it used to. Which is good. Now, I'm going to try give it another light bulb. Give it a bit more voltage. It's now got 140 watt bulb in the dim bulb test. It's seeing 217 volts, drawing 170 milliamps. And the volume has come up noticeably. Okay, now that is medium wave. What happens if I switch it to one of the other bands? Can't remember which one was working. One of these is long wave, one of these is short wave. Okay, that's long wave. This is our Porto Santo beacon. This is early afternoon, so we shouldn't get much here anyway. This is that station from Morocco. Let's try shortwave. This is the one we had nothing on. And it seems we have nothing on it still. Okay. Back to medium wave and off. So what have we found? We found that the bands that were working continue to work. I think the sound is better. The volume is better. Obviously, it had to do with a lot of those capacitors that we replaced on there. And the shortwave band, which was not working, continues to not work. Let me switch off the dim bulb supply so we don't have any mishaps as I turn this thing around. Because the obvious next step is this part here. All this section over here. Obviously, I'm going to start with the supply wires that come from there to this section. Check the band switch. Maybe that's why the shortwave's not working. It could be one of the coils that's broken. So there are a few things. The shortwave circuit's very simple at this front end. It either works or it doesn't. There's not that much that you need to look for. But that's my next task. And it should be a lot easier now that I've got the hang of rewiring. So it's not as daunting as it was when I first started because, you know, you just become a little bit cockier. And that's when mistakes can happen as well. But yeah, another thing that I'm curious about is I need to find out how these tuning adjustments work, what sort of capacitors they have in there that allow you to tune the IF. I need to check the IF. So there's still quite a bit to do on here, but this thing is staring at me. No question about it. And that, my friends, is all for now. I want to thank you for watching. I hope you've enjoyed that. I've been enjoying this more than I expected. I really am. This is going back down to, the nitty-gritty, the grassroots of wiring and everything else. I even made an attempt at this looming system. Didn't work too well, but I might fix that up a bit. Once again, hope you've enjoyed that. If you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Links at the end of the video and in the description below. Thanks for watching. Bye for now, and stay safe.